Hello, this is Mr. Collier, and today we're doing tree diagrams. Okay, let's take a look at this first simple tree diagram. So this is on the way to school, passing traffic lights. Probably I'm delayed at the first light is 2/3. So let's display that in a tree diagram. We got 2/3, and then the complement of that is 1/3. So 2/3 chance of delay, a 1/3 chance of not being delayed. Okay, and this is the second day. Is delay, not delay. And on the second day, if I'm delayed, the probability of being delayed on the second day is 3/4. So this is 1/4, and then this probability is half. So not delayed is half here. So this is the Venn diagram. What's the probability of being delayed twice? That's a delay on the first day, delay on the second day. That is just this branch right here, 2/3 times 1/4, which is 2/12 or 1/6, if you will. Let's leave it as 2/12. Okay, delayed exactly once means delayed on the first day, not delayed on the second day, plus not delayed on the first day, delayed on the second day. Those are the two possibilities. And that represents these two branches here, this one and this one. So let's put in the probabilities. 2/3 times 1/4 plus 1/3 times 1/2. And if you put that in, or do it manually or put it into your calculator, it should spit out 1/3. Okay, next we are looking at, let's get down to this question here. Okay, we got a bag that contains some marbles. Let's make a tree diagram. Okay, there's 4 red and there's green. Okay, so it's 4 out of 9 chance of red, 5 out of 9 chance of green. And the 2 beads are picked at random, and the first is not replaced. So it's not replaced, so this, after the first pick, there's now 8 total beads. The probability, now there's only 3 red ones left, so there's going to be 3/8. But for green, there's still 5 green, and there's 8 total, so it's 5/8. These two should add up to 1 as well. So here, if you pick a green on the first pick, then there's only 4 green left, and we have 4 out of 8 here, and 4 out of 8 here. So now we can answer some probabilities. Find the probability the second bead is red, given the first one's green. We don't need the formula because given that first one's green, and the second one's red, is just this branch right here. So it's 5/9 times 4/8. Actually, it's not even that, it's just 4/8, right? Given that the first one's green, then we just read this probability right here. If we were to use the formula, let's just verify that it's correct. Then we'd have R2 and G1. Oops, let me rewrite that, sorry. So we have probability of R2 and G1 divided by probability of G1. Well, R2 and G1 is 5/9 times 4/8. It's this branch right here. The denominator is probability of the first one being green, which is 5/9. So you can see the 5/9 cancel, and you simply get 4/8 there, right? Or 50%, if you will. Okay, so remember B, probability the second bead is red. Well, that could be red, red, and green, green. So we're going to do probability of red, red, plus probability of green, red. Okay, so that is going to be red, red is 4/9 times 3/8 plus 5/9 times 4/8. And that gives us 32 out of 72, or 4/9 if you simplify it. Part C, probability the first one's green, given that the second one's red, now we have to use the formula. Well, that's probably the easiest way to do it. It's hard to visualize from the tree. Okay, the second one's red is actually our answer from part B, so we put in 4/9 there. Green 1, red 2 is just this 5/9 times 4/9. Okay, so if you type this into a calculator or do it manually, you get 5/8. Let's take a look at D. Probably the first bead is red, given the second bead is red, is probability of, well, both of them being red, divided by probability the second one is red. That equals probability both of them are red is this top branch here, 4/9 times 3/8. Divided by our answer from part B, which was 4/9. So actually you can see it's just 3/8, right? Because these just cancel, which makes sense. We're given that it was the second one was red. We just need the probability the first one's red. It's just 3/8. Okay, next part E, probability the first bead was red, given at least one of the beads was red. So we're given at least one red. Okay, now that equals probability, the probability the first one's red and at least one red, divided by probability at least one red. So the first one's red and at least one red. Well, if the first one's red, it's automatically at least one red. So that's actually just 4/9. Okay. You can also add together this probability and this probability right here, and you also get 4/9. And the denominator at least one red, probably at least one red, is, do we have that one already? Nope. At least one red is 4/9 times 3/8 plus, well, actually this is probably easiest to do, 1 minus probability both green. That's probably the best way to do that. That's the opposite of at least one red. So it's 4/9 over 1 minus probability they're both green is 5/9 times 4/8. So we type that into our calculator, we get 8/13. Okay, next, bag contains 2 red discs and 8 blue discs. I pull out 2 at random. If the first is not replaced before the second one is drawn, find the probability the second disc is red. So let's draw a Venn diagram with red, blue. Not a Venn diagram, tree diagram. This is 2/10 and 8/10. And we got red, blue, red, blue. Now there's one less red disc, so it's going to be 1 out of 9. And this is going to be 8 out of 9, of course. In this case, the first one drawn is blue, so there's still 2 red, but 9 total. And now there's 7 red out of 9 total. So that's our tree diagram. Now let's work out some probabilities. Probability the second one is red is probability the first one's red and the second one's red, plus the probability the first one's blue, the second one's red. So looking at the Venn diagram, we got 2/10 times 1/9 plus 8/10 times 2/9, which gives us altogether 18 over 90, or 2/10, 20%, or 1/5 in simplest form. Any of those forms are acceptable. On the probability the first one's blue, given the second one is red. Okay, so we need a conditional probability formula. Probability the first one's blue and the second one's red, divided by probability the second one is red, which is our answer from part A. So first one blue, second one red is here. It's 8/10 times 2/9. And if we work all that out, we get 8/9. That is 8/9. Okay, one more thing, which does apply to Venn diagrams as well, the at least one concept. This is a bit hard to work out. If I roll a dice 4 times, what's the probability of at least 1/6? Well, you can have 1 6 or 2 6s or 3 6s or 4 6s. You can add all those together, but it's easier to do 1 minus probability of no 6s. So each time you roll, the probability of not getting a 6 is 5/6. So probability of not getting a 6 4 times is this. Okay, and if you type that into your calculator, you get 671 over 1296, or if you want to see it as a percent, it's 51.8%. So the probability of at least one is 1 minus probability of none.